All right, good morning, everyone. It is week 13, day 2. Let's see how you all did on the second set theory quiz. I posted a little Venn diagram here showing the relationship of different shapes. I did this because my daughter is actually studying these shapes right now, and she was getting kind of upset because in kindergarten, they would show you a shape, and you're like, rectangle, right? And then they show you another shape, and that's square. And a square is not a rectangle in kindergarten, right? And so she was having a hard time understanding that all squares are rectangles, but not all rectangles are squares. In other words, squares are a subset, a proper subset, in fact, of rectangles. And I blame that, on the simplification of kindergarten, right? They don't have time to teach people set theory in kindergarten, but she'd come out of it with this notion that squares and rectangles are two different shapes, and they're not. Oh yeah, that's fine, Chase. So let's see how y'all did. Pretty good, pretty good. All right. All presidents of the U.S. Donald Trump. Yeah, so maybe some of you didn't know who's been president of the U.S. Trump and Biden have both been president, despite the fact that people of the opposing political parties often say, not my president, both ways. Donald Trump is not my president. Joe Biden was not elected properly. Whatever. They're your presidents. At least if you're here in America. All presidents of the USA, Donald Trump, Joe Biden, are presidents. McCain and Kerry are not. McCain lost to Obama. Kerry lost to Bush. So the intersection of set A and set B has two people in it, Trump and Biden, and the size of that intersection is 2. Right. So Google for the win. Who these people are. Yeah, that's fair. That's fair. All right, so again, this is the size of the vertical bars are the size of the set, so we're looking for 2. I haven't given you any ones really that have had infinite sets. We should probably talk about that. And then for the second one, we've got a proper subset thing. If you took the quiz early on, it was a subset of or equal to operator. And a student rightly posted me that you could just put down the same set for all 5, and it would be technically correct. So I changed the quiz. I figure probably most of you didn't see this anyway. 30 students, I guess, are completely AFK at this point. So I don't know what's going on with you. It's not hard. Just do the work. All it really takes to get an A in this class is just show up every day, do the daily participation. Get an A. Just have to pass some tests. Okay, so so squares are a subset of rectangles. Rectangles are a subset of parallelograms. Parallelograms are a subset of quadrilaterals. Quadrilaterals are a subset of polygons. So, there you go. All right. So, let's talk about infinite sets a little bit. So, there's actually different sized infinities. The concept of a larger infinity seems kind of counterintuitive, right? Like, how can you have more than an infinite number? All right. And as it turns out, you can. So, or rather, there's different sizes of infinities. And so the size of infinity that we usually talk about when you talk about like how many integers there are, how many whole numbers there are, that's something called aleph null. All right. And that is the size of the infinity of integers. Now, you might be asking, like, all right, well, if an infinity can be bigger or smaller than another one, like, okay, here's a question for you. True or false? There's the same number of even numbers, even whole numbers, even integers. The size of the set of all even integers is the size of the set of odd integers. What do you think? True or false? In other words, if you I were to write down, z plus is positive integers. We can write, we'll just write evens. What is the size of evens? Is that equal to the size of odds? What do you think? True? False? Now, a couple lectures ago, I showed you a picture of sheep and leopards. Okay, and the what I said was if you can have a one-to-one and onto correspondence between each element in a set and a corresponding element in the other set, then they're the same size, right? And that's rather obvious. You got 5 here, you got 5 here, and you can draw a line between each one, right? Now, we can do the same thing with even and odd numbers as well. So if we were to make the background here white or something, you can say, make a function f of x, which is equal to x plus 1. If you remember your algebra, this is a one-to-one and onto correspondence. In other words, if you input 1, you get 2, and if I give you 2 on the right-hand side, you can get 1 out of that. And so for every odd number, there is exactly one even number that it corresponds to, right? So the size of odds is the same as the size of evens. Okay, that makes sense? Because for every odd number, and you could do it, in fact, you could do it with -1. It doesn't actually matter how you do the one-to-one and onto correspondence, as long as you can come up with a function that will take an element of the set on the left-hand side, return a set on the right-hand side, and you can do the same in the opposite direction, then it's a one-to-one and onto correspondence. In other words, you just draw a line between each of the numbers in the set. So for example, we have 1, 3, 5, 7, 9, and we have a set containing 2, 4, 6, 8. Who do we appreciate? That's a 9, believe it or not. You can just basically draw a line between one element in the left-hand side. These are the odds, of course, here. These are the evens here. Right, and then that makes it a one-to-one and onto correspondence. In other words, it's the same size. Does that kind of make sense to those of you? Maybe you haven't had algebra in a while. It doesn't really matter. Just kind of conceptually, does it make sense? If you can draw a line between each element in a set and a corresponding element in the other set, they're the same size, right? You can just see this visually, right? You don't have to count how many leopards there are. You don't have to count how many sheep there are, because you can see there is a line connecting each pair. Okay? So there are the same number of evens as the same number of odds. All right. So what is bigger? The number of... Where's my mouse? There it is. What is bigger? The number of odd numbers or integers? Are there more integers or are there more odd numbers? Odd integers, right? So in other words, odd is 1, 3, 5, 7, 9, 11, -1, -3, -5, down to infinity. And z is just all integers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., right? Which set do you think is bigger? Are there more odd numbers or are there more integers? Odd and even integers, right? So z is the union of odd, there goes the O, union even, right? So the set of integers is the set of all odd integers unioned with the set of all even integers. And some people have this weird idea that 0 is not even. 0 is an even number. So integers are the larger infinity. Yeah, it makes sense, doesn't it? But you're wrong. There's actually the same number of integers as there are odd integers. The size of both sets is Aleph null. I told you, infinity gets weird. So the size of this is, and you draw like this weird crooked in kind of thing. The size of that is Aleph null, and the size of that is Aleph null. There's actually the same number of integers as odd integers, and the same number of even integers. In fact, the size of integers is the same as the size of odd integers, and it's the size of even integers. And it's also the same size of integers divisible by 1,000. which sounds like that's impossible, right? Well, check it out. We have odd numbers here. We have all integers here. Is there a way of making a mapping between odd integers and integers? Right? And in fact, there is. Like, if you want to go from actually, it's easier to do it this way, right? You just say 2x plus 1, right? So if you push in 0 as the input, you get 1 as the output. If you push in 1 as the input, you get 3 as the output. If you put in 2 as the input, you get 5 as the output, right? This is a one-to-one and onto correspondence. It goes the other way as well. If you put in 5 on the right-hand side, you get 2 on the left-hand side. If you put in 3 on the right-hand side, you get 1 on the left-hand side. Okay? Therefore, the size of all odd integers is exactly the same as the size of all integers. And it's also the size of all positive integers. And it's also the size of all integers that are divisible by 1,000. And it's also the same size as even integers. Seems amazingly counterintuitive, right? Does that hurt your brain a little bit? Chat just got real quiet. Yeah. But it's provably true, right? Because you can do you can draw for every number in odds. Let's call this leopard 1, 3, 5, 7, 9. These correspond to 0, 1. Yeah, 1. Where's 2? 2, 3, and 4. Right. So for every element in Z in integers, there's one element in odd. And for every element in odd, there's one element in Z. Therefore, they are the same sized infinities. And it's like, what? You know, that's true. It's provably true. So if you understand that they're the same size, if you can do this, it works for infinities as well. So, infinities like break a lot of our common sense notions, right? Now, here's another question. So let's talk about floating point numbers, right? As we call them in computer science. And so you can have a number like 0.5, 0.6, 0.7, 3.1415. It's a terrible one. Let's fix that little. Right? You guys understand? Numbers with decimals, right? So what is bigger? The size of all integers or the size of all numbers between 0 and 1, floating point numbers. So this includes like 0.1, 0.2, 0.3, 0.4, right? Do you think there's more integers or do you think there's more floating point numbers, you know, numbers with decimals, you know, whatever, however you want to call it, real numbers, between 0 and 1? So one person. See, people are like just scared to say anything. Don't be scared to be wrong. You know, if you knew all this stuff, you wouldn't be in the class, right? So that's what you're here for, all right? Yeah, 0.111111111 would be in the right hand side. Okay. Wouldn't it be the same? I don't know. You tell me. Guess. Same amount? So, yeah, now that I've set you up to think that the infinities are the same size, this one is actually bigger. It's infinitely bigger. There are more decimal numbers between 0 and 1 than there are all integers. And how? Well, try this, right? So you try mapping like 0 to like 1, and then you try mapping 1 to like 1.1. and then 2 is like 1.11, and 3 is like 1.111, right? You can't ever even get to 1.2, right? There's an infinite number of, like, you can just go down this pathway as long as you want, always adding another 1 to the end of it until you, you know, you just go forever, right? Until nothing. You don't have the brain cells for this? I know. This is why I like teaching, because it hurts your brain so bad. But that's what's fun about computer science. And you're not really expected to have a good intuition on this. It's part of the fun. Like, computer science stretches your brain and, like, hurts it. And you're like, I don't like this. Okay. So, yeah. So that one's bigger. I'll do one more, and then I'll stop torturing you. At least on this subject. All right, what is bigger, integers or fractions? Rationals, as they're called. Right, so fraction could be something like 5/6 or 7/10, or, I don't know, 2/3, something like that. Are there more integers or are there more fractions? And of course, fractions include the integers, right? So you have like 5/1, 6/1, What do you think there's more of? More integers or more fractions? You'd say fractions, but it's probably that they're the same. Emily's paranoia is more integers, just going with the counterintuitive. I don't think it could be integers, right? Because obviously there's more fractions than integers, like from a common sense perspective, right? Because for every fraction, for every integer, there's a corresponding fraction that's that number over 1, right? So there's no way of having more integers. But the question is, are there more fractions or are they the same size? And yeah, so everybody got it wrong again. Yeah, awesome. So there's actually the same size. There's actually an equal number of integers and fractions. And the proof of this is actually one of the more brilliant proofs in math and computer science, technically, which is if you make a table of all fractions, and these are like the numerators, and these are like the denominators, and this is like 1, 2, 3, 4, 5, and this is like 1, 2, 3, 4, 5. This would be like 1, and this is 2 and 3 and 4 and 5, and this is like 1/2 and 2 halves and 3 halves, 4 halves and 5 halves, 3/1 and 3/2. Oh no, sorry, I'm doing this backwards. 1/3, 2/3, 3/3, 4/3, 5/3, and 1/5, 2/5, 3/5, 4/5. It's a 4, I promise, and 5/5. What you can actually do is say, all right, from Z, Z element 1 corresponds to this guy here, 2 corresponds to 2, 3 corresponds to 1/2, 4 corresponds to 3, 5 corresponds to 2 halves, 6 corresponds to 3/3. And what you do is you travel through the matrix like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's actually a 1-to-1 non-to correspondence from every integer to every fraction. You punch in a number, you get a fraction out. You punch in a fraction, you get a number out. There's exactly 1 on each side. This is called the diagonal. I think it's like Cantor's diagonalization. And it's one of those things where you're just like, huh. Right? Huh. Let me see if I got the name right. Cantor diagonal argument. Okay. So, controversy. Yeah. So if you guys are like upset over it, believe me, mathematicians were too. And yeah. What do you guys think? Was that fun in sort of a brain-bending sort of way? On the quizzes, like I said, if I give you a quiz question that has a infinite set, I'll just ask you to punch in like -1. Normally set sizes can't be negative, right? So, all right. Yeah, and doing things like Venn diagrams oftentimes help a lot with set theory as well. So you can kind of visualize squares are inside of rectangles, and rectangles are inside of parallelograms, and parallelograms are inside of quads, and I don't know, polygons on here, but yeah. Logic with logic. Logic plus facts equals logic. That's this whole class, I think. This whole class is just logic and facts. All right, so you got a new Zybooks assignment. The Zybooks assignment is set theory. So, Zybook. Now, there are multiple Zybooks. Zybooks.com. There you go. And so, yeah. It's going to be due on Wednesday of next week. And it's just basically the sets thing here. So, a couple sections. If there's ever something where it asks you to like do something on paper, I don't care. I don't want to grade things on paper. Like these additional exercises here, I can just make them visible, you know, so you can like see the answers if you want to check yourself. Because these questions are going to be like, you know, on the, you know, final, right? So you can get some extra practice in, you know, see if you know what you're doing. Okay. Any questions about set theory before we move on? Nothing? You're all 100%? If I asked you a question about the sizes of two different infinite sets, how confident are you on a scale from 1 to 10 that you would be able to get it correct? That's all the final is going to be. It's just all questions about infinities. Oh Lord, that'd be so mean. Are there more complex numbers or? Nah, you're not really supposed to know that. So, no, don't. Infinitely confident. You're Aleph null confident. Okay, nice. No, I'm not gonna ask you to compare infinities on a final. However, like if you do a set union or something, then you might end up with an infinite set. In that case, you put down -1 as the size. That's reasonable, you know. The set of all numbers that is not 7. That's an infinite set. What's the size of that set? Aleph null. And so on the quiz, you punch in -1. And it'll say that. You don't have to remember that. Okay, so like I said, we finish off every semester with doing a little bit of Python. Python is an easy-to-learn programming language. In computer science, there's a number of programming languages that we use to control these wonderful beasts we call computers. At Fresno State, most of the program is in C++. C++ was a language invented by Bjarne Stroustrup, who is a great guy. I like him a lot. Bjarne Stroustrup. Yeah, I've met him before and talked to him, traded emails with him a few times, not a lot. He's a really great guy. I like him a lot. And he invented it at Bell Labs in the late 70s, early 80s, and that's, you know, one of the predominant programming languages used today. Python is what we're about to learn. Python is considered a very easy to learn language. I don't necessarily think it's any easier or harder than C++. I think the differences between languages is kind of exaggerated, but you know, there's probably something to it. So Python is the most popular language today. C, which is what C++ derived from, is second place. So if you put C++ and C together, it's 20%, you know. Because you learn you learn C, you kind of learn C++, or the base, or subset of C++. Subset, see, told you it's in the vernacular. Java is a spin-off of C++. C# is Microsoft's version of Java. Sorry, did I say that loud? It's a similar, it's also a spin-off of C++. And so basically you've got these four programming languages here that are all very close. They're not the same. It's like the difference between like Spanish and Portuguese, and then like Spanish and Italian. You know what I mean? And like Latin and Italian. You know what I mean? Like there's these Romance languages that, like my mom was a college Spanish instructor actually, which is why I never learned Spanish. See you, Chase. But like when we went to Italy, my mom would kind of muddle her way through, Italian because she spoke Spanish fluently. And it's kind of like that with these languages here. So these four languages are all like there's large chunks of the language you could just copy from one and paste in another, and it would compile and run the same way. And then you get into abominations like Visual Basic and JavaScript. SQL, that's the database stuff that I was telling you about. PHP is kind of garbage, but I don't hate it as much as a lot of people do. I guess it's used in websites and things like that. You can have code generate a HTML page for you. R is used for data science kinds of things. Python's used in a lot of data science as well. If you're interested in doing data science, Python and R are both the premier languages in that field. Fresno State has no data science major yet, but there is, in the math department at least, there is a sort of like a specialization you can do in data science. Do you guys know what data science is? Data science. You guys heard of this before? I've worked with Berkeley's data science department for years. And like 3 or 4 years now, probably, trying to spread their Data 8 program to other colleges. Nope, nobody? Okay, well. Basically, data science involves like getting a large data set, processing it, and doing some sort of analysis on it, right? So for example, a common, actually right here, yeah. Nate Silver is the famous pollster for 538. He predicts elections and things like that. So he looks at data and uses it to make predictions for elections. And, famously got Trump's election wrong, as did, everyone, basically. Almost everyone. Not everyone, but almost everyone got it wrong. A classic data science problem would be like looking at the survivor data set from the Titanic and then making a prediction, like if you hear, hey, there was somebody who worked in the Italian restaurant on board the Titanic, because the Titanic had a pay restaurant in addition to the first class, second class, and third class dining saloons. They had a pay Italian restaurant called the Ritz, or Giovanni's, I think. And if I selected a waiter from the Ritz, what are the odds that person made it? Or if I selected a woman from third class in the front part of the ship, what are the odds that she survived? Right? That's the kind of it's a very simple data science, application, but that's the kind of thing you do. And businesses hire data scientists left and right. Like, it is a hot field. Colleges can't hire data science professors because they're all being offered a lot of money to not be a professor, to work in industry. So we're going to be doing a little data science here. And this is a part of a partnership between Microsoft and I think NASA, and I think Berkeley may or may not have been involved in the development of this. So we're going to be learning Python at the remainder of this class. And that'll do you well, because even if you're not a... you've heard of it, not sure what it is. Yeah, I can bring in one of my former students. She's graduating, I think, this semester, and she's kind of a data science. She's kind of a data science. Just ran my knee into the table. She's kind of a data science person. I can have her give an overview of data science for you if you want. but they do a lot of Python and R. And so even if you're not a computer science major, learning Python is valuable for you because, you know, it's an easy to learn language. You don't have to go hardcore into computer science to know how to do a little bit of programming. Python's nice like that. It's really easy to get started. And then, like I said, there's a whole bunch of, like, it's the most popular, language in the world right now. So even if you are a computer science major and you've never learned Python before, well, there you go. Get to add a new language to your resume. Get hired. Okay, make some cash. All right. So this is what you're going to do. So this is a let's see, 8 units. Let's see here. There we go. There's the other units. Okay. Let me copy and paste this into chat, and I will put this into the Canvas assignment as well. So basically what you do is this. So you're going to have to go, I think you have to log in. I think if you don't log in, you're going to be a sad panda. Because it doesn't save your work, and then you can't show me that you actually did the homework assignment. Okay, so you see here how it's worth 5,000 XP. When you complete it, when you complete a module, you collect experience points and you level up. I don't know what that means. It's not like you get a magic item or something, but what I want to see is all of these gems filled. So there's a couple different modules here, and you just basically run through it. Now, here's what it looks like using notebooks. Okay. I'll just jump midway through it. Sign in. Yeah, you have to sign in. I'll use my Berkeley login. If that works. Nah. Let's see here. So always the hardest part is remembering your login. Okay. Yeah, Berkeley set up an account for me, and it's probably timed out. I haven't used it in a while. All right, so I got 2 hours to do this. All right, more sandboxes will be available tomorrow, so don't try to. I don't know. Like I think that should be plenty of time actually. You can probably complete this whole thing in 2 hours, but you still get 10 sandboxes. So that's cool. Okay, so here we go. So here's what it looks like. I've jumped to the middle of the assignment, and we've got here. Let me zoom in. This is something called a Jupyter notebook, and this is one of Berkeley's big things. Jupyter notebooks are like interactive notebooks, like in science, you'd have a notebook. And what's cool about them is that you can run, like you can type code into here, and you can hit run, and then it runs it on the sandbox. So there's actually a data center running these things, and eventually it will come back. There we go, and tell you 9. Okay? I hope I didn't blow anyone's mind here, but in Python, this is valid Python. You can just type 3 plus 6, and it will print to the screen 9. Okay? So this is an entire program. This is way easier to get started on than like C++ or Java or something like that. In Java, you have to have a public static void main, blip, 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 blip. And in C++, you have to have hashtag include IOStream using namespace. Now, in Python, you can like run Python, and I'll show you on my own machine here. Python 3. You ready for this? 3 plus 6, 9. Are you guys intimidated yet by the programming? This is real programming. This is the most popular programming language in the world. Is this too intimidating? One divided by 0. Uh-oh. All right. And so what's happening when you do the Jupyter notebooks is that it actually sends this program to a data center, and it runs it, and then the output appears like right here. Okay. And you can change the code. So I can change this to 3 divided by 6 and hit run. And okay, it didn't take 9 million seconds this time, so I got 1/2, right? And if I do integer division, then I get 0. So 3 divided by 6 is 0 with a remainder of 3. So it's maybe a little too advanced. All right, 3 divided by 0 is going to be explosion. Okay. You guys with me? And so you can just punch code in here, hit run, and it tells you the output. And then you can do subtraction and multiplication and division. And you can combine things and use parentheses. Are you guys cool with this? Like, this isn't rocket science, although technically it's rocket science. Right? It's literally rocket science you're doing right now, but it's not rocket science. Do you have to use cout or cin with Python? Great question. If you have an expression like this, like a mathematical expression, it just prints the answer. If you want to cout something, there's something called print. And so hello world is your traditional first program in computer science. And so there is a function called print. And print will print whatever is within it to the screen. So, yeah. No cin, no cout. Cinning is via input. And then you can print the value of x. And so there's a function called input, and it reads a number or anything really from the keyboard, and then saves it into a variable named x. And then if you print the value of x, it'll do 55. Or you can just type x, that's an expression, and we'll print the value for you. Variables work like this. X is equal to 2 plus 2. And then you can just print the value of x like that. X gives you 4. Or you can say print x if you want to type more. X is equal to hello world. So, yeah. Does that make sense? You do algebra. You make variables. You do input and output. And then as you run through the Python Jupyter notebooks, it'll run you through how to do an if statement, how to do a for loop, this kind of stuff too. This is exponentiation, double stars, double multiply is 10 to the 5th power. And then this is integer division here with the double slash is integer division. So 5 divided by 2 is 2 with a remainder of 1. And this gives you the remainder. So 10 divided by 3 has a remainder of 1. So we run that, you'll see that it gives an answer of 1. 10 to the 5th power is 10 to the 5.37. 5 divided by 2 is 2. And so you just run the code here. You don't have to have a development environment like I have here. No, you just do your thing, And then when you finish it, you hit next, and then if you go back to the future, if you go back to here, you can see it puts a checkbox on everything you do, right? So when you complete a unit, it fills in that diamond. So I've got 1200 XP there, 1000 XP there. I haven't done control statements yet. Control statements are like if statements and things like that. And so what I'm going to ask from you is for you to simply screenshot that you've done it. That's it. So could you just click your way through this? Probably. Would you be able to solve a very simple programming problem on the final? Probably not. So at least pay a little bit of attention to it. Like this isn't CSI 40. I'm not teaching you to program really in this class. This class is more just for people that have never programmed before to just do a little bit of scratch things, like the little animations and things like that. Learn this, really, really kind of simple stuff here. You're not expected to write World of Warcraft or something. Okay, it's really, really simple stuff. All right, and then just screenshot all of it, put it up on Canvas, and that'll be that. That's then we'll probably do one more thing with Python after that. So, but this, this is kind of designed for like, I don't want to say elementary school kids, maybe like middle school or high school kids. You know, it's just a really easy introduction to programming. C++ can be intimidating to some people. Kind of depends how they teach it too. C++ can be made to be really hard, or it can be made to be pretty easy, and it just depends on your professor, really. Python is always kind of easy, so that's probably a benefit to Python. Yeah, and there's one other thing we need to talk about, which is the end of the year essay. So the end of the semester is coming up. I think it's like in the last day of school is, it's like 2 weeks from today, I think. Is that right? Or is it 3 weeks? It's 2 weeks from today. And then there's like consultation days. Does that sound right to you guys? Last day of instruction is the 11th. Consultation days are the 12th and 13th. Is that? Anyone know when the end of the semester is? I think that's right. Double check. Okay. Good. Students always are more aware of when class is in than professors are. I'll just talk forever. All right. So and then finals week is here. So finals week, you have the entire finals week basically to take the final. It'll work the same as the midterms. Basically, it'll probably open on Friday after class. Well, there's no class on Friday, but I'll probably do a final review on that Friday if that works for you all. These are consultation days, so I figure it seems like a good time to kind of go over all the topics in the class, talk about what's on the final, and then at 11 o'clock on Friday, it'll open, and it'll close probably a week later. I need to see what the actual technical end of the finals week is, but it's usually like a week or something like that to do the final. And you can take it at any point, same as before. You get a couple hours to do it. It's 30-ish questions, not designed to murder people. I've been collecting some memes that have fallacies in them, so I've always found that it's a little bit harder for students, like when you look at a meme to identify the fallacy in it. May 19th is the last day. Okay, yeah, so it'll go from the 13th to the 19th. Okay. Yeah, it's always harder, or like, you know, social media screenshots and things like that, but again, it's not designed to like murder people. So. Yeah, so there is a end of the year essay that you have to write, and that will be posted on Canvas. Basically, it's going to demonstrate your ability to do all three types of reasoning, and there's different topics that you can write on, and there'll, you know, the topics that we've talked about in this class: the social issues in computer science, algorithmic bias, and corporate censorship. Actually, we've already done corporate censorship, so I'll probably not do that one because we just did an essay on it. I don't want you double dipping on that. And on the Theric as well. We've already done one on that. So I'll basically make a list of the topics we've talked about in this class, and you have to write an essay. It's part of your GE requirement. So what happens is you submit it to the GE coordinator to show that you have successfully completed the critical thinking general ed requirement. It's got a word limit. It's not a page limit. It's a word limit. I think it's 1,000 words, if I remember off the top of my head. I always, you know, double check before, saying things. So I think it's 1,000 words, something like that. And you have to use three types of reasoning in it. You have to use deductive, abductive, and inductive reasoning. Deductive reasoning is if this, then this. You know, like the syllogisms. All this are this, but this is not this. Then this is not this. Yeah. Deductive reasoning, inductive reasoning, based on experience with things in the past, we can make this prediction about the future. Inductive reasoning, and then abductive reasoning is based on the relative pros and cons, the evidence for, the evidence against. We can say that there's more evidence for this than against it, therefore it's probably true. You must use all three forms of reasoning on your essay and demonstrate it to me, and bold the parts that you think are that type of reasoning. And when I read your essay, I zoom in with a laser-like focus on those three parts, and I validate that you have, in fact, learned what inductive, abductive, and inductive reasoning are, and that you can demonstrate it. And that's really what you get graded on. So I don't, like I said, I don't care about grading about spelling and grammar and things like that. This isn't an English class. English professors will mark you down if you misspell things. I guess I will if it's so jumbled I can't read it, But basically, I want you to demonstrate to me you've learned things in this class, right? And specifically, what you're being assessed on is the three types of arguments, and that you understand one of the social issues in computer science we talked about: driverless cars, algorithmic bias. Um, you know, maybe we could even do like, I don't know, something with set theory. No, that's not really a social issue. I don't know, if you can squeeze 1,000 words on set theory, I don't know, I'd probably allow it. Be interesting, be different. Fallacies, obviously. Um, the impact of social media, digital ownership. What it means to own things. We should probably talk about that at some point in the semester. Twitter mobs and cancel culture. There's a lot of topics that we've either talked about or at least alluded to in this class that would be fair game for the essay. So that'll be due at the end of the semester. So we have the Python coming up. We got a Zybooks coming up. And then towards the end of the semester, we're going to have the final and the big GE essay. After you do it, you submit it to the GE coordinator. I don't do that for you. That's on you. That goes into your portfolio that demonstrates that you've completed the different criteria for completing the class. Okay. And then, as always, we have the daily quizzes, the daily participation, round out the class strong. If you're worried about your grade, make sure you participate. Like there were 30 students that didn't take the last quiz, and then, probably half of those are going to message me last week like, I haven't been taking the quiz. Is there anything I can do to get my grade up? And the answer is just do the quiz every day. Like, like they didn't even take it. Like they didn't even take the quiz, right? So do that. It's a lot easier to be proactive than reactive when it comes to your grades, because there's probably going to be like one more extra credit availability in the next 2 weeks. But just better to just do your participation, do the quizzes, and that preps you for the essay and it preps you for the final. So seems like a good plan to me. All right. So Simran, any other questions on the kind of end of the semester? We got exactly 2 weeks left from today. Although technically on the 13th I'll be doing a final review. So yeah, whether or not you count that as class doesn't bother me. It won't count for attendance. That's for sure. Is the final going to be open for a certain time or for a couple days? It's going to be open from the 13th to the 19th. So it'll open at 11 a.m. on the 13th and run through probably midnight on the 19th. Whatever. I'll give you guys the maximal amount of time to do the final. But once you start it, it's a 2-hour time limit, right? So it's the same as the midterms. It's basically the same format. And the reason why I put a 2-hour time limit on it is not because it takes 2 hours to do. It takes 45 minutes to do. Like if you look at the time that it takes students to do the test, it's like half an hour to 45 minutes. I don't want you to feel like pressed for time, but at the same time I don't offer infinite time, because then you will spend infinite time, and I want you actually not spending infinite time, right? You have other finals presumably, right? And also, I don't want you just being like, oh, like just watch all the lectures then and get the answers. No, you need to prep for it and study and things like that. Don't cram everything in the last minute. Okay. So that is it for today. Thanks, everyone, and I will see you on Friday. Peace out.